Okay, hey, how are you doing? This is going to be the last one. This is the last skill. This is the last everything that you're going to need for this year. Making it very simple. There will be just a small little test that'll be in Go Formative. I promise you it's just stuff right from here, okay? All right, so let's go. Okay, so what this is all about is basically, you guys ask, when am I going to use this? Well, when you're talking about figures and 3D figures, this is all over our world, all over in many, many jobs, construction, building, playgrounds. It's everywhere. Your house you live in, everything. So to me, 3D geometry is probably one of the biggest real world type skill. Okay, so this you guys probably remember from pre-algebra. This is your figure. This is more rectangular. This is your box. Basically, the edges are these pieces here. The vertex is the same as a vertex anywhere you've seen it this year, and it's a corner. And the face is the part that makes up the whole thing, okay? And some faces are going to be all equal like this one. Some faces are going to be different sizes and areas. Okay, you don't have isometric dot paper, but if you do have a printer and you can get Google and you can find one, you could actually draw this. If we were in school, we would be drawing this. I also have they're like geometric boards, and you use rubber bands and you create these things. So we are missing a lot with this one as far as not being in school. Okay, so this one, it tells you to make your box 3 wide. So we're not even going to go over that. That would be this, but to me that looks like height. So I'm not really going to go over this. But if you have dot paper, you can go ahead and try it, or you can print dot paper. This is called perspective. I remember when we were kids, we used to draw these all over the place, just make boxes. These are all two-dimensional figures. Each one, J to K to Q to R is a rectangle. K to Q to P to L is a rectangle. But when you put them and smoosh them all together, it becomes a three-dimensional figure. And now it looks like it has depth to it. You can fill it up. Okay, if we were in school, I have hundreds and hundreds of blocks, and we would have built these type of little figures. I would have had you just play with them and compare your figures to other figures and count your blocks and etc., etc. But of course we're not. So we're going to just look at it on here. If I looked at this, if we had built this, what I would have had you do, okay, so that's what these 3 figures are for. I would have had you get up and look over your figure, just down on it, and this would be what you see, okay? These are called I'm not sure if that's orthogonal. To me, it probably should be orthogonal drawings, but I don't remember how to pronounce that. This is if you came back and you looked at it this way. You would see 1, 2, 3, 4 up, 1, 2, 3, 4 up, and 3 across. You wouldn't see it in a 3-dimensional way. You would see it 2-dimensional. And if you went to the right side, you would see it the same way. Okay? That's basically it. I wish we could actually do these, but we can't, so it's okay. Okay, so now we're going to talk about filling them up. Prisms, cylinders, all of that. This 3 right here means that you are talking more than just a surface area, the 2 numbers you multiplied. Now we're talking about also depth. So that is going to be 3 numbers that you will be multiplying. So that's not the best reason, but that's one of the good reasons for using the 3 and remembering to use the three numbers, 3D, however you would choose. Okay. Volumes of prisms and cylinders. Many of you drew that when I asked you to do your little laboratory, the introduction laboratory. Lots of us have those in different pieces. This is a prism. There are different prisms. This is a cubes with squares. You also have triangular prisms. You also have rectangular prisms. Prisms are identified by their bases, okay? Now, we'll get into each one of these, but if all 6 faces, which is what I was saying before, are all squares, then you have this Rubik's Cube, and it is a cube. This is a triangular prism. Here is why. Because its base and base, 2 bases, are triangles. I know you have rectangles, but if you have a triangle, that's why it's going to be called a triangular prism, okay? There are formulas. Not even going to worry about these right now as far as solving them, but I want you to know how to do them. The volume of a triangular prism is, if you notice the B is capital BH, but really what that means is the capital B is the base, and the base, if you remember, is 1/2 length times height. So you would have to know, I'm going to go over to this one, you would have to know the height of the triangle, and you would have to know its base and divide by 2. That's where the B, the big B, comes in. It just kind of shrinks the formula a little bit, but you could also say length times width times height divided by 2. That would not be a problem. B, oh, that's an H, by the way. And then divide by 2 because your length times width is your capital B. Okay, so we'll solve some of these in just a little bit. I'm going to let you try some. Here's another view. This one on the left here shows you how the prism looks in a 3-dimensional way. But if you did what I asked you to do before, or I would ask you to do in your classes, looking down on it, then you would see its 2-dimensional base. So we're going to look at solving these. I do want to say there was a number here. So if you're looking at this and you're thinking there's something missing, what I want to explain to you is if we took this triangle out, this is a right triangle, and that is the hypotenuse. Okay, so it's not necessary right now. I'll show you later. But we have your base here, and we have your height here. Okay, I'm sorry. I'm going to change that to be base. Okay, and then your length. Base, or let's do this. It's also width. So now you have, and I'm going to show you a formula. It's going to look confusing, and then I'm going to show you what you could do to make it much easier. For here, you have 3 numbers, and that's where you're going to come back and use those 3 numbers. The 4th number there that I took away was just a trick. Okay, so here's your formula, and I put both of these, base times width, I put height. So either, I'm sorry, not base times width, base or width, height and length. So here is that area of the triangle, your 12 times 6, and then times height. But watch how they do this, okay? They turn that into 0.5. 16 times 12. And so please don't get confused. This is the area of that one, triangle. Okay. And that's this one here. Okay. So you're not finished. So then the base times height, or base height, is going, the height is 12, which I labeled it a little different, but it's still the same three numbers, I promise you. So then you do the 96 times 12, the 96 area of the triangle times 12 length or height, however you stand it, and you end up with 1,152 cubic inches. So that's the volume. But I want to show you something. This is a lot to think about. Let me explain. If you did 12, that's one of your numbers, times 12, another number, times 16, all three of those multiplied, and then divide all of that by 2, guess what? You get 1,152. So although this is very technical and correct, this is much easier. Okay, so this is a rectangular prism, and here's the thing of why you can't call it a square prism. A square prism would be a cube. This is clearly not a cube, because a cube is going to have all of its bases the same square. So it's called a rectangular prism because it has rectangles in it. And you guys, when you did your 2D, 3D lab, you identified that as shoe boxes, as a box, whatever it was, okay? And the formula for that is the same. Your base, which is this, length times width, times your height. So basically, it's just going to be whatever three numbers they give you multiplied together. All right, so let's look at this. I'm going to give you a minute. I'm just going to pause myself and give you a minute to try it. So I'll talk you through it. The base is your length times width. Then you multiply by h. So I'm going to give you a second. Okay, hopefully what you did is you took 12, 8, and 3, multiplied them together, and got 288. But please, please, please do not forget to add that part in. That's your tag or your measure, okay? And so that is the volume of this in cubic units. Here is a three-dimensional view of a cube. This is, again, if I look down on top of it, I can clearly see that no matter how I turn it, I could take it, turn it this way, this way, this way. They're all squares and they're all the same. This formula is the same as the rectangular prism. If it's a prism, there are three numbers: LWH, length times width times height. So I'm going to give you a second to give me the volume of this cube. And hopefully you took the 3 5s and simply multiplied them together. This comes from algebra. you could write it this way, or you could write it this way because they both mean the same thing. And you get 125 cubic units. We don't know the units, so we're just going to leave them. Units cubed. Cylinder. Same base times height, but in this one, the base is a circle. And if you remember, because we just got done with circles, pi r squared, which is pi times whatever your radius is, squared times height. This is just a different little piece of the base formula. And as long as you have the numbers, the R and H, you got it. Sometimes you'll be asked to leave it in terms of pi. Sometimes you'll be asked to use pi. So take a moment. I'll get you started on this part. This part is going to be pi, which is 3.14 or just plain pi. And 4 squared is 16. Oops, sorry about that. 4 squared is 16 times, I don't know how to go back. Let me see. I hope I don't mess it up. There we go. Okay, times 16 times 10. I can't remember how I solved it, whether I used pi as 3.14 or I left pi, but we'll see, okay? Okay, let's see what I did. I can't remember. So pi times 4 squared, which is 16, and I did that, times 10. So I did use pi, I just can't remember. So 3.14 times 16 times 10 gives us 502.4 cubic centimeters. And that's measured also cubic units because it has depth. Even though you only used 2 numbers here, you really used 3 because you used your 4 twice. So 4 times 4 times 10. Okay? Or you could look at it as saying I used pi also. So either way you look at it, it's going to be 3 for the cubic units. Okay? Now this one, I'm not going to actually use this with you. I don't even think I put anything like this on the test. But it is going to be something, especially if you're going to college. I want to say probably in your later maths, changing dimensions. So I'm not going to really ask you to do it. I just want to show it to you so you're familiar if it comes up again anytime in the near future or in college. So if you look at this, it says that a juice box measures 3 by 2 by 4. I'm not sure which one's which, but I'm going to label 3 by 2 by 4. Okay. And I believe it says explain whether doubling the length, width, or height of the box doubles the amount of the juice. So here's what we're going to do. We're going to look at this. The volume of a 3 by 2 by 4, 3 times 2 times 4 is 24 cubic units. If we double the length, which I'm going to call this one, doubling the length is 3 here. So the length is 6. The other 2 stay the same because it only tells us to double the length. Well, when you do that, 6 times 2 times 4 gives us 48 cubic units. So you compare that to the original, which is 24. So it is 2 times greater if you double the length. Well, let's look and see what happens if you double the width. And of course, we're going to call this one the width. And 2 plus 2 is 4. So now we have 3 times 4 times 4 because instead of 3 times 2 times 4, the 2 got doubled. 3 times 4 times 4 is also 48 cubic inches. So it is 2 times greater. If we double the height, and the height here is 4, if we double that to 8 and take the other two dimensions as they are, 3 times 2 times 8, the volume is still 48 cubic inches. So if we double the height, it is twice. But I don't want you to think of this word doubling tells you that it's going to be twice whatever it asks you to do, because it's not always going to happen. It does happen with the rectangular prism. It will happen with the cube, but when you start looking at other figures, it will not. If you double something, I want you to see what will happen. Okay, so here we've got a juice can, and I'm going to try and put this in here. The radius is 1.5 and the height is 5. So look what happens when you have a can. So now we've got pi r squared, which is our can lid, times h. 3.14 times 1.5 times 1.5 times 5 gives you 11.25 pi. The pi in this case didn't get used, so we left, sorry about that, we left pi alone, so pi stays. So this is just to show you what happens in when you double, okay? So if we are going to double the radius, so now we're going to double the radius, so this is then going to become 3, because 1.5 plus 1.5 is 3. So now your can lid is much bigger, but your height is still going to be the same. So if we double it, pi, and remember we leave pi, I've forgotten about that. We leave pi there. We take 3 squared times 5. We end up with pi times 9 times 5. 9 times 5 is 45. Well, now look, we doubled the radius, but if we were to say, well, then the volume is double, 11.25 and 11.25 pi is going to be 22.5. That's not correct. So when you look at this, you need to say, well, how many times greater is 45? So if you took 11.25 times 2 for doubling, didn't work, right? Okay, so then times 3, then times 4, you would find out that this is now 4 times greater. And you can actually just memorize these later without having to do them. Doubling the radius in a can, 4 times greater, but you need some practice with that. And then if you look here, doubling the height, and I won't even go through all this, but if we double the height but leave the radius alone, now it is 2 times, sorry, let me get rid of that. Now it is, 2 times greater. That's it. Okay, so you have to try them in order to truly see. So that word double can be deceiving. Volumes of pyramids and cones. I want to, I so wish I could do this with you. I want to explain the 1/3, okay, because that's going to be an important part of the formula. And I also want to explain something else that's actually not in here, but I'll explain it when I get a little bit in. Okay. All right. So, and I tried to be real sensitive to move everything. I guess I didn't do a good job with this one, but it's not covering the pyramid too much. So pyramid's named for a shape. We already did that. It is a square base with 4 sides. Okay, so if it's a triangular base, it has 3 sides. So this here, now we're going to look at the cone. The cone has, and I'll see if I can do this, has a circular base. Here is, and here is your radius, and here's your height. That's all you need. Now, this I'm not going to go into. This S is called slant height. It's a little different, and I'm not even going to worry about that. You'll get that later, okay? So here we are. This, I want to explain. This is the formula. Just trust me for right now. I'll explain the 1/3 in just a little bit and you'll understand. It's still pi r squared times h, but instead of like the triangle, you divided by 2, I will explain a little bit. This time, you divide by 3. So I want to show you what that means. So you would have to find the area of the base. So pi 7 squared times its height, but then you would have to divide by 3. So for just a moment, trust me on that, and I'll show you how that works. Oh, I'm sorry. I thought I moved everything. So I've already explained this. The pyramid's known by its base. Its formula is the same, but because we don't have a circular base, it's simply length times width times height, and then you divide that by 3. So I don't know what that number is under there, and I can't see it, but let's just take this as 1.6 times 0.4, and let's just say this is 1 down here, I can't remember, times 1, and then all 3 of those would get divided by 3, okay? Again, just trust me for a few minutes. You'll understand that 1/3 in a minute. Here it is. So, this is the volume formula for when you have a circular base. This is the volume formula when you have a square or rectangular base. Here's where the 1/3 comes in, and this is where I wish we could be in the classroom. I have bags and bags of little tiny bags of rice. If you took that rice and you filled up these figures that I have, you could take that square pyramid and fill up the cube 3 times. So that means one of them and one more of them and one more of them will fill up the cube. So the square pyramid is 1/3 of the cube. And it's the same thing here. If we were in the classroom, we would fill up the cone. We would pour 3 cones into there. So the cone is also 1/3. So hopefully that helps you understand that formula. It always helped me to remember it. Okay. So we're going to find volumes. I'm going to sit back. I'm going to let you have a minute each to solve the problems, and then I'll reveal the answers for you to try. Okay? Hopefully my video is not in the way. Okay, so try this one. Here is your radius, and here is your height. So fill it in and see what you can do. And I'm going to reveal the answers. So you take, and of course, I probably should have told you, use 3.14, but it didn't really matter. 3.14, your 3 radius gets squared, and your 8.6. When you multiply all of them together, you get, and I dropped off the 0.3036. So nearest tenth, if you had the nearest hundredth, it would have been 0.4. If I round to the nearest tenth, then everything kind of drops off. But I'm not even worried about that part. Okay? How'd you do? I hope you did well. Now try this one. Very, very, very basic. 6 times 8 times 2. 30 seconds. And 6 times 8 times 2 is 96. I'm assuming that's pretty decent. Again, like I said before, you got this in pre-algebra, so this really should just be a review. Nothing new. Okay, so here we're coming back. We actually, I think we already did this one, so I'm just going to go ahead and reveal again. Your 1/2, 12 times 16 times 12. 1/2, what they did was multiply, or what I did was multiply 12 times 16 is 192 times 12. Again, it basically just multiplied these 3 numbers and divided by 2 to get 1,152. That's it. Okay, this is just going to be very quick, and okay, this is a sphere. It's called an anamorphic image. Spheres are really, really hard to draw, okay? And with the sphere, it's sometimes difficult with the surface area, and surface area means we're going to cover it. It's kind of like if you got a soccer ball for Christmas and you had it wrapped and it's still a ball, okay? It's very difficult to cover that with wrapping paper because you have all this overlapping stuff. But it's what you do if you take a circle. It's what you do with the circle inside. I'm going to try. That makes it look spherical. Okay, so a sphere is kind of a strange figure. What I do want to show you about the sphere, and I'm not talking about surface area right here. We are going into surface area, but if you were going to find how much air fills in that soccer ball, I want you to see something. This is the formula. There's such a huge explanation for this that I can't really do here because I would need to go through a whole process with you. But what I did want to show you is if I were filling it up with air, where does this come from? Okay, well, 4 spheres. Okay, are used to fill up like we did last time. So that's where the 4 comes from. So I just really wanted you to see that formula. We're not even going to really use it, but I did want you to see it. And again, pre-algebra, maybe or maybe not, your teacher explained that. Okay, I love this whole thing about the cereal box. The volume of the cereal box is how much cereal goes in it. The surface area of the cereal box is how much cardboard. Here's the fun thing about volume. Do they really fill up the cereal box? No, so you really don't get full volume of it. But the surface area, you can't mess with that. You've got a side here. You've got a top. You have a side. You have a side. You have a bottom. So top and bottom, side and side, and front and back. So you have 6 sides. 3 sides are doubled. So basically that's what you get with that. I did put some of this in the test. This is not really something that you're going to be required in geometry anymore, but I do like it, so I wanted to look at this. It says when you flatten out this figure, this is a cube, okay, it opens up to what's called a net. So of A, B, C, or D, what is this opening up to? All right, so we're going to compare these nets. If I folded this up, I'm going to have open sides, okay? If I folded this up, I'm going to have one open side. If I folded this up, I'm going to have an open side here and an open side here. This one, if I folded it up, these two will close up a side, and these two will close up a side, and this will close up the top. So C is your net. Sometimes they're a little difficult. This one's not too bad because you can actually see it here. You have two, side, side, and top and base. I actually meant two here, sorry. And this surface area is exactly what I said. If I took a square off, very, very old math says that I need to find the height and the width. And then, of course, we have depth. So you would have one number times one number times one number for volume. But when you're doing the surface area, I'm going to wrap this up, or I'm going to use cardboard to make it. I need X times Y, and I need that 6 times. So 6 times X times Y, okay? So I need that much cardboard. This just explains it. If I took that box and I moved it and I turned it around for you to see different views of it, it's all the same. Every piece of it, just like a dice, except the dice numbers distinguish their side. Surface area of a cylinder is going to be the area of the circle, which is pi r squared. And then your height, that's called your lateral surface, that's going to fold out, and I'm going to show you what that looks like. That's going to fold out here. So we need to find 2 areas of circle, so it's 2 times that pi r squared h, which is the base, and then this is 12. Wait a minute. This is 12, and this, believe it or not, sorry, I messed that up. That is the circumference of the circle. So you would have to find the circumference because that unwrapped from here. And then your circumference, if you remember, is pi d. And d in this case is going to be 6.2. If it's in terms of pi, 6.2 pi. If it needs to be completely solved, it's 6.2 times 3.14. This is just showing you that if we cut up a triangular prism, we end up with 2 triangles on each side and 3 rectangular bases. Okay, so I'm going to just go through these for you because this video is getting pretty long. Basically, if I were going to find the surface area, I would have 2 times 8 times 6 plus 2 times 8 times 2 plus 2 times 6 times 2. And the 2 comes from, you have 2 sides that are alike all around. That's 6 sides. 96 plus 32 plus 24 and that equals 152 square centimeters of cardboard or wrapping paper or whatever you were going to do with it. Just pause this if you want to give it a try yourself and see if you get the same answer. Cylinder, that's one that we actually already looked at it. We have two areas of a circle plus the circumference times the height. So that is going to be pi times 3.12 squared, pi 6.2, and 12 using all of those numbers. So you would add them together because you have two top and bottom and you have one rectangle. And there you go. Okay, I'm going to go through these pretty quickly. If you need to go back, just go back and look at them. Okay, and this is the one I was telling you. When we got here, you would see that now I'm giving you that hypotenuse. It had nothing to do with the volume, so that's why I left it off. But in order to do surface area, we do need to have that. So I'm going to reveal the formula. Surface area is two areas of a triangle plus length times width plus length times width plus length times width. Okay, so you have two areas of a triangle and you have three other pieces. Okay, and there's all the numbers popped in. Here's where the 20 comes in. Can't leave that out because we need to have the area of that triangle. And then you simply multiply and then add. Okay. Epcot is our sphere. New Year's ball that drops is our sphere. Just a fun little picture for you to see. And as I said, it's everywhere. 3D, 2D figures, everywhere. 3D figures, of course, more. I just wanted to show you this, and then I will be all done. I do want you to understand one thing, and I'm not going to go over it and ask you to solve anything using it, but I want you to know what a cross-section is. If I have a loaf of bread, my loaf of bread, this whole loaf of bread is a rectangular prism of some sort. When I cut it, it's 2D piece. Depending on your loaf of bread, it is either a square or a rectangle. That is called a cross section, where you section it, where you cross cut it. Okay, but there is also other ways to cut it. If I cut my bread, and this is hard for me to try. I would have demonstrated it in class, but this is kind of hard. So if I started up here and I cut through it this way, and I tried to do that, cut through it this way, then what you would have is you would have a piece like this. Okay, I would more call that a parallelogram instead of a rectangle. It would have been much easier to see had I demonstrated that for you. So no big deal. This I just popped in another picture for you. If you have this, believe it or not, I know we've been calling it oval. It's really called an ellipsoid. Let me see if I can remember how to spell that. Okay, you definitely will see this later. Algebra 2, probably pre-calculus, calculus. When you cut the ellipsoid, guess what it does? It stays an ellipsoid, but it is the 2D shape of the ellipsoid. That's just an idea of what a cross-section is, guys, so I'm not really going to do much with that.